Hello, my name is Thomas Albrechtsson, and I'm a university professor who I've devoted my career to osseointegration of implants. And I started with it almost to the day 50 years ago in 1967. But the man who was behind the innovation, the discovery, perhaps one may say, of osseointegration wasn't me. It was in fact the head of our department when I started working there in the 1960s. And this is a documentary how osseointegrated oral implants were developed in Sweden by a physician named Per-Ingvar Brånemark, PI, and how his findings were applied clinically despite initial opposition from dentists. Brånemark was a researcher, initially known for his studies on microcirculation. And here you see him in 1959, when he receives the insignia as a PhD of the University of Lund in southern Sweden. At the time, he hadn't worked yet with implants. He was given a position at the University of Gothenburg by the early 1960s, and there he decided to continue his research in microcirculation. Here you see images from the human blood flow in volunteers of the department, and these images where you can see white blood cells, red blood cells, they are from the year between 1961 and 1968, and they are still today, 50 years later, the highest power images available of live human microcirculation. Now, Brånemark constructed a hollow titanium implant where blood vessels grew into a prepared space at the level of the arrow. And then, since the implant was hollow with glass rods, he was able to transilluminate the blood vessels that had grown through this chamber, he called it, titanium chamber. And he could analyze things in the light microscope and do various types of experimental studies on it. Now, Brånemark was different from most researchers. When he found his titanium chamber placed in those animals, stably anchored in bone, he immediately saw clinical potentials of his findings. And the year was 1962. It took him only another 3 years before he placed his first oral implants in patients. That happened in 1965, and you see here two of the original Brånemark implants with flanges. That we wouldn't use such things today, of course, but those were the preliminary implants used then in the very first patients back more than 50 years ago. Brånemark discovered what was later to be called osseointegration in 1962. Here you see him when it all began with implants, and what were his concepts of the early days. He was convinced of direct bone anchorage and of clinical success of his implants. The problem was, in those days, in the 1960s, we had only histology, and we saw only 50% success of our clinical oral implants. Mind you, the patients we treated in those days would be regarded difficult to treat even today. Those were patients who had had dentures for quite a while, and their alveolar ridges were resorbed, so they were very difficult patients to treat, particularly without bone grafting. So that to part explained the poor results in the beginning, but also there was a learning curve, how to place the implant, when to load the implant, etc. And it took some time for the team to understand this. This, what you see here, is a model implant only, placed in a toe of an elephant that we harvested somewhere from a zoological garden. He tried to overcome shortcomings of old histology by developing a sort of cutting and grinding technique, but Not with the resolution we have today, of course. The resolution was too poor to really prove that he had a direct bone-to-implant contact. And this, at the time, famous cell, was it an osteoblast or only a fibroblast? Well, it's very difficult to say for certain, but you see the cellular processes, whatever type of cell it is, that is sort of walking onto the irregularities of a titanium implant. Animal experiments continued in parallel to the clinical work. Dick Skalak, then at the Columbia University in New York, was an international co-worker of ours, and he came overseas to Gothenburg to perform biomechanical testings, as you can see here. Despite all these research efforts, and despite publications on oral implant in Scandinavian Journal of Plastic Reconstructive Surgery in 1969, 71 and 1975, the collected evidence was rejected by Swedish academic dentists. They were convinced at the time that oral implants didn't work and direct bone anchorage was considered a myth. In fact, it wasn't only Swedish dentists, this was the general opinion of those days of academicians in dentistry from all over the world. So we had indeed the worst academic struggle in Sweden since the war, culminating at the annual meeting of dentists in Stockholm in 1974, when there was only one dental academician defending Brennemark's histologic concepts. So finally, in 1977, 3 independent dental academicians from our northernmost university of Umeå traveled down to Gothenburg, picked patients at random from our clinical theatre, and they looked at these patients, invited them for examination, and they wrote the first positive academic statement ever authored that implants, oral implants, perhaps works after all. Here you see Brennemark when we traveled in North America by the beginning of the 1980s. He had indeed learned how to walk on the trails and only stay on the trail. It took him quite a few years. With the advent of Donuts, a German investigator, cutting and grinding equipment, direct bone anchorage of his implant was finally confirmed. But now we are perhaps well into the 1980s, when this image here was presented, where you see bone tissue brownish to the left, you see titanium implant black to the right. And you can see that at the resolution level of the light microscope, there is indeed a direct bone contact of the implants. The clinical concepts of Brennemark, we identified together 6 factors for reliable osseointegration: implant biocompatibility, implant design and implant surface, state of the host bed, surgical technique, and loading conditions, and published that in the Orthopedic Journal of Scandinavia in 1981. You may be surprised that we published our papers in Plastic and Reconstructive Surgery and, as in this case, in an Orthopedic Journal. But in those days, there were no oral implant journals whatsoever. And if we tried to submit our papers to a dental journal in general, they would immediately have been rejected, because internationally people did not believe in oral implants. So here we start then with the biocompatibility. We compare different materials, and you can see commercially pure titanium in an animal study to your left, and titanium 6 aluminum 4 vanadium alloy after about 3 months to your right. And Brennemark's advice was use only commercially pure titanium, because that will anchor more rapidly than would other materials such as titanium alloys or other metals for that matter. The implant design, we decided early on to have a threaded type of implant. Implants without threads were launched later on, but found to be clinical catastrophes, and they were later removed from marketing. Which thread pattern is the best? Well, we haven't been able to, even to date, 50 years later, to demonstrate whether one pattern is better than the other. Then we started investigating the implant surface. We had started ourselves with a minimally rough implant with a so-called SA value of 0.9 micrometers, but in animals we found evidence that the strongest bone reaction is seen to implants with a little bit rougher texture of the order of 1 to 2 micrometer SA, whereas if we enlarge the rugosity even more, then the bone responses are weaker again. So modern implant surfaces, indeed, they are moderately roughened. They have an SA between 1 and 2, and other surface characteristics would have to do with chemistry that some companies now attach to their implant, or physics by changing the surface energy, or even with nano roughness that I will soon come back to. Then we had the state of the host bed. How is the patient? We realized early on already when we started with the implants that if we had a good and healthy bone bed, that would be preferable, of course, to one that had various types of problems, including infection or severe bone resorption. Low ridge height, osteoporosis, previous irradiation are not contraindications for implant placement, in some contrast perhaps to ongoing bone infection that we would have to treat first before we place the implant. Minimally traumatizing surgical technique was something that we found extremely valuable if we wanted implant success to ensue. Well-sharpened drills, slow drill speeds, graded series of drills. If we want to drill a 4 millimeter hole, we don't start with a 4 millimeter drill, we start with a 1 millimeter, and then we gradually enlarge the hole that's less traumatic to the tissues. And of course, all the time, adequate cooling. To this day, we have clinical evidence that what may cause failures more than perhaps anything else is our clinical handling of the implants, at least if one uses the control type of implant systems that are around with proper clinical documentation. Then the human being, the clinical handling is very important for the outcome. And in the clinical handling is of course included the loading conditions of the implant. We thought in the early days we wanted to avoid movements in the interface. So we decided in all cases to place the implant at day 0, so to speak, and then we sutured the soft tissues above them, gave the patients an adjusted denture back, and they couldn't use their implants. The implants were left in situ to be osseointegrated or incorporated into bone. And then 3 months later, if we had a mandibular case, we would recall the patient, open up again, and now connect a bridge work or an artificial tooth or whatever to the implant. In the maxilla, we wanted to wait in those days maybe 6 months or even more, particularly if we had fragile bone in the maxilla. This is a safe procedure, of course, to use 2 stages, and we still use it sometimes at our university. But we know today that we can be more, if you are skilled with implants, we can load them much more rapidly. We can even load them the same day with good clinical outcome. Brennemark's concepts were found applicable in other fields of medicine, indeed, than dentistry. And the first spin-off product we started with was in 1977 with facial implants. This poor fellow here was a crab fisher from Western Australia, had been out too much in the hot Australian sun and developed a mid-face tumor. And you can see that the surgeon had to treat him by removing his nose and also the upper palate. And he couldn't talk properly. But by putting implants, in those days we used a bridge work looking like this, and then attaching a silicone epistasis, the situation indeed improved a lot. And we have this gentleman who lived for 20 years with his implants. he traveled sometimes around with us when we lectured and demonstrated how implants could help him. Those were the facial implants, and we continued 2 years later with the external hearing aids in 1979, the first cases. The idea here is to place an implant behind the ear of the patient and then attach a hearing aid that sort of then is directly bone anchored, which gives much better hearing conditions. We reserved this treatment originally to patients with problems in the ossicular chains, with the malleus. They had either defect malleus, incus, or stapes, and then we used this technique for them. And one of our very first patients was a girl who had thalidomide embryopathy, a drug given to mothers, a tranquilizing drug, without having tested it on pregnant animals, and children were born without limbs and also with hearing defects. And it was a great reward to the team, of course, when this young girl learned how to speak at the age of 15 after she had been given this type of directly bone-anchored hearing aid. The first papers we published about these two techniques internationally, that happened in 1981. Then today we have seen about 200,000 patients treated with external hearing aids and what we call facial epistasis. You see here an ear. You can see it's a cancer case, and the tissues were irradiated. You can even see on the left-hand side the eardrum of the patient, and then you let the patient have an artificial silicone ear that he himself can snap on to his implants. In northern countries, they usually had a couple of ears, one a little bit darker version for the summers, and one a bit whiter version of ear for the winters. Now, the next spin-off product were high amputee cases, and that followed in 1987. I mean, the common treatment when you have an amputation is to use a socket prosthesis, but if the level of amputation is very high, such as in this case, there isn't flesh satisfactory for the socket prosthesis to work. And the idea then was to implant a fixture, we call them, into the rest of the femur. You can see this fixture protruding to the right in the picture. And then we can attach an artificial limb to the fixture in this manner. And this is a treatment that we started quite a few years ago, as late as, I think it was 1 year ago in 2016, or was it perhaps 2015, was finally accepted for treatment in the United States. Resonance frequency for analysis, RFI, for stability measurements was a technique developed at the University of London in England from the technical work and the clinical experimental work at our department. And this is a commercial technique by which you can put an energy input into to the implant. Today doesn't look like these, like you see here. These are the old illustrations we used when we started working. Today it's done much more electronically, but it's a method to evaluate whether the implant is stable or not in the bone, and it gives you then figures of how stably the implant is anchored. Fifth spin-off, orthopedic implants. We had started early on in the 1990s with hip implants, and you see our hip implant here made of commercially pure titanium with a gliding surface of zirconia. This is our Mark I hip, and we placed it in a randomized controlled trial. You see our hip here to the right in the left femur, and the control in the right femur, or to the left here. We had in the beginning similar results, but after changing and now launching our Mark II implant that you can see here, we have now had improved results, and they have functioned very well indeed. Our implants for more than 10 years in clinically. We have published the first 5-year data, and we are now writing the 10-year clinical follow-up data of these new type of hip implants. Here you see Brennemark again in a more recent photograph. He was born in 1929 and passed away in 2014. To give you an idea how the man was thinking, the term osseointegration wasn't used in the first 15 years, although he certainly claimed that there was a direct bone implant contact early on. But this is how Brennemark coined the term osseointegration. He consulted a professional linguist of our university and told him, I have bone here and I have implant there, and they somehow unite. What shall I call it? And the linguist received 200 British pounds for his suggestion, osseointegration, and that was in 1976. And as you know, today we have academies of osseointegration, not only in the United States, but also in Europe, in Japan, in Australia, and other countries. So the term has had a frequent usage, and this was how it once came about. In 1978, Brennemark took out a patent on the importance of nano-sized surface indentations for proper osseointegration. In 2017, nanosurfaces represent the research frontier, and within a few years I'm positive we will know whether he was right or wrong. Finally, one of Brennemark's strong concepts that he taught us, his pupils, was that we must have at least one patient a day to be able to do proper research. A recommendation I have personally tried to follow. Here you see Brennemark to the left with Mr. Larsen, who was our very first patient treated in 1965. Mr. Larsen passed away in 2006. I've told you now in my first lecture how we had these innovations coming, and everything, of course, seemed to be very smooth and everything was very fine, but that isn't the reality when you develop new clinical treatment possibilities. On the contrary, we had a lot of problems at times, and we almost had to abandon our plans to continue in oral implantology. So I will talk about, in this lecture, about the past, how we perceive the present and the future at various times from 1962 and until today. You see, every time we learned something from the past and adapted this to the present, the future looked very bright. Lamentably, always to be followed by what then seemed to be disaster. And from this disaster, we learned something and so on. Presenting a slide that you saw before, Brennemark in 1962, where he looks very happy because his implants have been found stable in the bone, and he's now going to apply this clinically. He sees a bright future and decides to place oral implants in his first patients only 3 years after those animal experiments. The year was 1965. You heard that before. It was the dawn of a new era. Success for the future in 1965. But Brennemark forgot to ask permission from the dentists. Disaster, of course, since our dental colleagues were used to lift out implants from patients using only their hands. And what can a medical doctor like Brennemark know about dental replacement was the general question. And the result was a rapidly widening gap between Brennemark's team and dentists proper. The Swedish dentists were indeed a trifle irritated. I told you before about the annual dental meetings in Sweden, where only one dentist defended us. He claimed he had really seen our histologic specimens and believed they were in direct bone contact. But this man, our only external friend in dentistry, fell down dead in a ruptured aortic aneurysm only 3 weeks later, and we felt at the time, I remember, abandoned by everyone. An almost united corps of Swedish dentists marched against osseointegration. And the future of osseointegrated oral implants seemed indeed a trifle pessimistic. But there was to be dawn of hope for the edentulous patients when all looked very dark. The Swedish Board of Welfare sent down 3 university professors from the Alpine University of Umeå. And these 3 academicians had found our implants stable in bone. And the implants were now to be again. And what a joy. Everything seemed positive. What a bright future we saw ahead of us. Our team was wild of optimism and we started training Scandinavian dentists in how to place oral implants. Hooray! What do you think happened? You are right, another disaster was to follow. Titanium ore that was imported from the Soviet Union was suddenly not exported any longer. And again, we had major problems. We were unable to manufacture our oral implants. Desperate as we were for titanium, we planned to open up a secret mine in the only Swedish supply of the metal called Smålandstaberg. But Smålandstaberg was a nature reserve heavily guarded by the environmentalists. We learned finally what had happened. The Soviets had manufactured a 12.2 meter high statue of Gagarin, entirely made from commercially pure titanium. And after the erection of this statue, the export started again, and our team members were just delighted. But we only saw a positive future. And now followed the Toronto conference held in 1982 that was to open up the international interest for the Gothenburg implants. You see here Per-Ingvar Brånemark and here George Saab, the host from the University of Toronto. And indeed, nothing could go wrong, we thought. The future was fantastic. However, despite what seemed success forever, the company behind that manufactured the implants did not sell that many implants. In fact, they saw only red figures in their report. And what does a company do when sales are poor? Well, they consulted with medical analysts. And they asked them then, is there any business in oral implants? Is there a future in oral implants? The analysts talked to dentists who informed them that even if implants worked, they were really not needed. Dentists had so many other viable alternatives for the edentulous patient. It was a pity that the analysts were unable to consult with a smart fellow like Nostradamus. Instead, he would have probably seen some economy in oral implants after all, a well-known European philosopher from the 16th century. But they didn't. And the general conclusion by the company involved was to avoid investing any more money in oral implants. Catastrophe for our patients and for ourselves too. From implants to be, they were again not to be. The company didn't want to put any more money into oral implants. Now, Brånemark and I, we traveled to the Swedish Investment Bank to ask them to invest money in the company to help them continue in the business. And we met with a man to the right. And when he did not play tennis with the man to the left, he was the senior manager of the Swedish Investment Bank that now invested 4 million euros into the company and saved it. And the future of oral implant now seemed safe again. Brånemark and I, we were interviewed by The Economist in 1967, and The Economist then reported that 600 dentists placed implants in 2017. We know that it's close to 70,000 US dentists using implants. And the world market is somewhere between 15 and 20 million oral implants annually. So indeed, implants were needed. But it's sometimes difficult, of course, to foresee that, to understand this, when you try to make an evaluation what is going to be needed in the future. But we saw great promise again for the future. We thought that our implants were now here to stay forever. But suddenly, we heard that our implants were too smooth, and that rougher surfaces were much better, which indeed posed a problem for us because our implants were, as I said before, relatively smooth. Now, the change to moderately rough surfaces were but a minor drawback, like the temporary flood. We just started to roughen up the surfaces and everything was fine again. Happy days are here again, and we thought they were going to last forever. Osseointegrated implants were so good again that everyone, with the possible exception of the paying patient, could really swim in money, until something happened. Again, implants not to be. And I have to give you now an abridged course in Swedish for friends from abroad. To be or not to be is in Swedish att vara eller inte vara. And var is the same as pass in Swedish. And you can see here pass around implants. Very skillful dentists, master about 0.25 cubic millimeters of the patient, started reporting that a most horrible disease entitled peri-implantitis threatened anywhere between 6 and 50% of our implants, a true clinical catastrophe. The future suddenly resembled the 1300s when the Black Death came to Europe. My goodness, why did we ever place an implant in a patient, we said to ourselves. What had been so good was suddenly a disaster. No sensible person wanted to even hold in his hands. Our previously solid dental bridges were allegedly lacking support due to galloping marginal bone loss that threatened the crossing to the shore of hope for the edentulous patient. Without proper bridge support, implant failure, of course, is imminent. But the reports in the dental implant journals continued claiming that implants displayed 95% or more of positive clinical outcome, over 10 years or more of follow-up, despite the alleged disease. And how on earth could that be even remotely possible? We didn't understand. We must learn what went wrong. Let us consider one study including a terrible outcome of 12.4% of old Brennemark implants suffering from peri-implantitis at a median of 12.5 years of follow-up, published by Fransson and co-workers about 10 years ago. Now, other investigators decided to analyze what really happened to the 12.4% of sick implants. And they did so on an average 9.1 years later. And the allegedly sick implants, they were of the 12.4%, they were now, to the potential surprise of the investigators, the sick implants, now followed up for 20 years, were after all quite good. In fact, 91.4% of the sick implants seemed to have almost a steady state situation with respect to further bone loss. And 95.3% of the allegedly sick implants were still in situ and supported bridges 9.1 years after having been diagnosed as sick specimens. Osseointegrated implants can be accepted again. They do fare well after all. And I can't foresee the future, but I'm convinced that something will threaten our implants again at some time. I don't know what it will be, but I'm also convinced that we can rest calm and collected in whatever swimming pool available, because oral implants have proven that they will survive just anything. And they are here to stay in the foreseeable future. Thank you very much, ladies and gentlemen.